Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. We have developed two programs for our LED interface. The first program was to switch on and off the LEDs with a delay of 0.5 seconds simultaneously, and second program was a counter running on these LEDs, and it was a free running counter. Now we'll interface 4 switches with our microcontroller and we'll use these switches to control our different programs. After interfacing these switches, we will use these switches to control the counter, that is to start the counter, stop the counter, and to reset the counter with the help of these switches. Here we can see in our schematic diagram that all 4 switches are connected with port D4, D5, D6 and D7 of the microcontroller. Here we can find digital input 0, digital input 1, digital input 2 and digital input 3. Here we can find that all these switches connected with port D, they have their one end connected with ground and the second end is pull up with a resistor of 4.7K. Here we can see in our schematic diagram that these switches are connected to pin number 27, pin number 28, pin number 29 and 30 of microcontroller. Now we will learn that how to interface switches with microcontroller. Here we have microcontroller and we have 4 digital inputs, that is pin 27, pin 28, 29 and 30. Pin 27 is port D4, 28 is port D5, port D6 and port D7. We will use 4 switches. Switch 1, switch 2, switch 3 and switch 4. One end of all these 4 switches will be ground. Here we have connected one end of all these 4 switches with ground. And second end of these switches connected with pin 27, 28, 29 and 30. We will use 4 pull-up resistors with these switches. The value of all 4 resistors is 4.7K. Now we can say that the input logic for these switches is active low. Because if no switch is pressed, the status of port will be high, and if we'll press the switch, the status of port will go low. If no switch is pressed, the logic level at any input will be high, and if we'll press the switch, it will go low, and when we'll release the switch, it will again go high. So we can say that the logic is active low. If we'll press any switch, it will produce bouncing at falling edge as well as at rising edge before going to low and high, and these bouncings can be eliminated using 2 techniques, that is hardware technique as well as software debouncing. Here we have the microcontroller which we are using in our prototype, that is PIC16F877A microcontroller. Now we'll connect all these 4 switches, that is switch 1, switch 2, switch 3 and switch 4 in our prototype. Here we have 4 switches and 4 resistors of 4.7K. Now we'll interface these switches and resistor in our prototype. We'll place the first switch at this position. We have placed second switch next to the first one. Now we'll place the other switches. Here we have placed all 4 switches in our Vero board. Now we'll connect these switches with microcontroller. Now we'll check if these switches are working properly. Okay, switch 1 is working properly. Switch 2. Switch 3 and switch 4. Okay, all switches are working properly. Now we'll connect 4 resistors of 4.7K as pull-up resistors. Here we have soldered 4 resistors of 4.7K with these switches. Now we'll connect one end of these resistors with 5 volt. Here we have 5 volt power supply connection. Now we'll develop a route to connect all these resistors with 5 volt. We will use a jumper connection to connect these 5 volts with these resistors. Here we have connected the 5 volt with pull-up resistors. Now we'll check the continuity of these pull-up resistors with 5 volt. Okay. And here we have 5 volts. Okay. We have connected all 4 resistors with 5 volt. Now we'll connect other end of all these 4 switches with ground. And here we have ground connection in our Vero board. So we'll connect the next end of these switches with this ground. Here we have connected the second end of all 4 switches with ground. And now we'll check the continuity of these switches with ground. Here we have pin number 3 of programming interface connected with ground. Okay, all switches are connected properly with ground. Now we'll perform a short circuit test between 5 volt and ground connection. Here we have 5 volts. And here we have ground. We will check the continuity of ground and 5 volt connection. Okay, there is no short circuit between 5 volt and ground connection. Now we'll connect all 4 switches with microcontroller. We will use a wire bridge to pass the wire from switches to microcontroller. Here we have soldered a wire bridge in our Vero board. We'll use another wire bridge near to microcontroller. We have connected 2 wire bridges to connect all these switches with microcontroller. Switch 1 is connected with pin number 27 of microcontroller. (21, 22, 23, 24, 25, 26 and 27). We have connected all 4 switches with microcontroller, that is from pin number 27, 28, 29 and 30 of the microcontroller. Now we'll check the continuity of these connections. Switch 1 is connected to pin number 27 of microcontroller. Okay, switch 1 is connected to pin number 27 of microcontroller. Switch number 2 is connected to pin number 28 of microcontroller. Okay, switch 3. Okay, switch 4. Okay, now we'll check the continuity of these pins with ground. If we'll press the corresponding switch, these pins will be connected to ground, that is pin number 27. It is not connected with ground, but if I'll press the switch, okay, this pin is connected with ground. Now pin number 28, pin 29 and pin 30. Okay, all switches will be connected to ground if we'll press any switch. Again, we'll perform a short circuit test between 5 volt and ground. Okay, there is no short circuit between 5 volt and ground. We have interfaced 4 switches with microcontroller. Now we'll write a program to read these switches and to display their status on these LEDs.